All right, so let's pick off where we left off last time. Just a little reminder, we talked about common functions. So we had about 8 of them, right? So we had our constant function, the linear function, quadratic, absolute value, and so on. And for your quiz, you have to know how to draw these and know the specific points on the graph. Okay. Then we talked about how we can take these common functions and shift them or compress them or stretch them into different types of graphs without having to plot like the actual points. So we did the vertical shift, the horizontal shift. Then we did the vertical stretch or compression. And then we finally left off with the reflection. Okay. Now, we did do a little mixing around with the shifts, so we were able to shift something vertically and horizontally at once. But we actually can combine everything together if we want, okay? So the next thing that I'm gonna do is we're gonna be given a function, and it might not just have shift speed onto it. It might have a shift, a reflection, and a stretch going on. And we're gonna figure out how we can do this all at once. Okay, so example 9 is an example of this, okay? And before I even start these questions, is the order that you do these actually does matter, okay? Now, sometimes it doesn't matter, but a lot of the times the order that you do things matters, especially when we have a horizontal shift, okay? And a vertical shift. Okay, so I'm gonna write my questions in a very specific way so that the order that you do things is always going to be the same, okay? So the way I'm gonna write my questions and how these functions are normally written is first you're gonna do any horizontal shift, okay? So horizontal shift is going to be the first thing you do. It's very easy to do, and I think it helps us a lot. Okay, after you do the horizontal shift, you're going to do any vertical stretching. Okay, so vertical stretch, vertical compression, that would go next. So vertical stretch or some sort of compression. Okay, once you're done doing the vertical stretching or compressing, you're actually going to reflect. So you're either going to reflect across the x-axis or the y-axis. So you're going to reflect. And then the final thing you're going to do is a vertical shift. Okay, so that's going to be the last thing that you're going to do. Now, I'm going to say a lot of graphs don't go in this order, but since I'm going to write all of these functions in like a standard form that mainly most classes follow, this is the order that I want you to follow. Okay, let's do this example here. Now, before we even start graphing, what do you think the original function of this graph is? Like, what would x squared, right? Because there's a square, so maybe I should start with x squared, okay? So actually, let's graph that function, and I'm gonna graph it here, okay? So I'm gonna graph the original function, which is just x squared, okay? What shape does x squared have? Parabola, good. And we had these 3 points that we knew we had to draw. If you wanted to draw other points, it was optional, but I'm definitely looking for this on a tester quiz. And this graph looks like a parabola or a U shape. Okay. Before we do any more drawing, let's figure out what's actually going on here. Okay. Let's see. Let's figure out what if there's any horizontal shifts. Are there any horizontal shifts? Yeah, and what is being horizontal, or how are we horizontally shifting? To the right too, right? And I think Marissa got that because she saw that there's an x minus 2 attached to the x. The 2 isn't being subtracted from the entire function, it's being subtracted from x. So this means that there is a horizontal shift to the right 2, right? So right 2. I know it's a little counterintuitive that when we subtract something, it goes to the right, and when we add it goes to the left. It's kind of just how these functions work. Okay, so we figured out our horizontal shifts. Are there any vertical stretches or compressions going on? Yeah, and how do we know that? Yeah, the half. So because of this half here, and it's being multiplied by my function, I know that I'm vertically stretching or compressing this function. And you don't have to know the difference. It actually is a compression, but we're multiplying the function by something. Okay, so we're doing a vertical stretch by 1/2. Okay. Finally, it looks like we have a negative sign. What is that telling us to reflect over? The x-axis or the y-axis? The x-axis. And it's the x-axis because the negative sign is not attached to the x itself. It's attached to the entire function. It sits on the outside of the function instead of on the inside. Okay, so because of the negative sign, we are reflecting across the x-axis. Okay. Any vertical shifts going on here? No, right? There's no vertical shifts. There's nothing being added to the function or subtracted to the entire function. So it looks like we just have 3 things that we need to do. Okay, let me tell you how I do this. Okay, so I have 4 graphs here, and I know it might be a little confusing. And if you can do this in your head, I am totally on board with you doing this in less steps than what I do. But I'm going to take each step, draw what happens after I do the step, and then do the next step on a separate graph. Okay, so I'm going to start with, so I started with this graph, which was the original function. The second thing I'm going to do is do the horizontal shift, right? That's the first thing we should do. So horizontal. And the graph that I'm horizontally shifting is the first graph. Okay, so in order to do horizontal shift, you're going to take every point on our graph and we're going to shift it to the right 2. So the point at the origin is going to go 2 to the right and become this point. The point here, 1, 1, this point here, 1, 1 is going to shift 2 to become 3, 1. And then the point negative 1, 1 is going to shift 2 over to become 1, 2. Okay. Or sorry, 1, 1. Sorry. Okay. Once we've done shifting all our important points, we can just make the graph based on the shape that it already takes in the last graph. And our graph should look something like this. That's not very good, but there we go. Okay, any questions about the horizontal shift? Good. All right, number 2 says we need to vertically stretch next. So I guess the next step that we have to do is take our graph and do our vertical stretch. Okay. Now, good question for you. Am I vertically stretching the graph of number 1 or number 2? Number 2, right? I've already horizontally shifted the graph. Since the next step is to vertically stretch, I need to start from where I left off. Okay, so I'm not vertically stretching the original function. I'm vertically stretching this function. Okay. Now, vertical stretch is when we make that table of points and then we multiply, right? So I need my x and y points. Okay. What are my original points that I'm starting with? Is 0, 0 going to be on this chart? 2, 0, right? We're doing the points from here. So 2, 0 is going to be on the chart because 2, 0 is a point on my blue graph. So 2, 0. It looks like we have a 1, 1, which is that point here, and we have a 3, 1 over there. Okay. What we do from here is I'm going to take my 1/2, which is the factor that I'm vertically stretching by, and multiply each point by 1/2. So 1 is going to become 1 times 1/2, which is 1/2. 0 times 1/2 is 0. And 1 times 1/2 is 1/2. Okay. So once I'm here, I have 3 new points to draw. I have 1 1/2, which is here. I have 2 0, and then 3 1/2. Once I draw these points, I can connect my line into the shape of a parabola. So it's going to look something like that. So from my blue graph to my orange graph, it looks like I compressed my graph. The graph is a little bit wider now. Okay. Any questions yet? All right. What's my final step here? What's the final translation I have to do? Yeah, we have to reflect across the x-axis, right? So I'm going to use a different color here, maybe maybe I'll use purple. It's a good color. Okay, final thing, I'm going to reflect across the x-axis. And what this means is I'm going to pretend the x-axis is a mirror. I'm going to take all my points and reflect them across the mirror. So 1, 1 gets reflected to, or sorry, 1.5 gets reflected to 1, negative 0.5. Okay. 2, 0 is on the mirror, so it stays. And 3 1/2 goes to 3, negative 1/2. All right. Once we're done that, we can connect our dots like we did before. And this is the final graph, right? I've done all the reflections that I needed. This is my final result. Okay. Any questions on putting everything together? All right. Oh, yeah. Oh, okay. Yeah, that's a good question. So Sarah's question was, what if I took this graph here, and let me draw this in like a dark blue color. And let's say I reflected it across the y-axis. Okay, so question, reflect across y-axis. Okay, it would be the same sort of deal, but now we're not like reflecting close to the y-axis, we're kind of reflecting away from the y-axis, right? So 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay, it would be sort of the same deal, but I would take this point 2, 0 and pretend that the y-axis is a mirror now. So this point would go 1, 2 to the mirror. It would go 1, 2 away from the mirror. Okay, so that 2 point will go to negative 2. Okay, 1 1/2 will be also reflected across the y-axis, which means the distance from the y-axis is going to be the same on the right-hand side and the left-hand side. So since it's only 1 block to the y-axis, it would be 1 block to the left of the y-axis. So 1 1/2 would go to negative 1 1/2. Finally, 3 1/2 is 1, 2, 3 blocks away from the y-axis on the right. So if I were to reflect it, it would go 1, 2, 3 blocks to the left of the y-axis. So we would actually have a point at 3, 3 1/2, negative 3 1/2. There we go. Once we're done doing that, we can actually just finish our graph like this. Yep. So this is what our graph would look like if we reflect it across the y-axis. That was a good question. Any other questions? Nice. Okay, how about if we flip our page, we will see another type of graph. I'm gonna give you some time to work on this one, and yeah, we'll come back in a little bit. Okay. I know that we're still working, but I do kind of want to go over this in person just because I've been seeing good answers as I walked around, but I do want to show like all the different steps just to make sure everyone's on the right page here. If you're still working, feel free to keep working, but I'm going to go over this real quick. Okay. We want to sketch the graph of 2 square root of negative x minus 1. Okay. So what's our original function here? Square root of x, good, because it has a square root, right? So it's pretty obvious we're starting with the square root of x. So I'm just going to write down my original function. And I think I told you that the points I wanted you to plot were 0 and 1. And I said that an optional point for the test or quiz would be 4, 2, right? But you didn't actually have to know that one. Okay. But our graph looks like this, and it kind of looks like a parabola on its side and cut in half. Okay. Remember that there's 4 steps, I think in order, kind of hard for me to memorize. First, horizontal stretches, 2 vertical stretches, or sorry, 1 horizontal shifts, 2 vertical stretches, 3 reflections, and 4 vertical shifts. Okay. Looking at our graph here, are there any horizontal shifts going on? No, right? There's nothing being added or subtracted to x itself, right? Let me give you an alternate example real quick, and you don't have to write this down because it's not related to the question. If it was like this, 2 negative x minus 1, this would be an example of a horizontal shift because the one's attached to the x. This question, the negative 1 is away from the function, so that's not a horizontal shift. Okay, so in this question, we don't have a horizontal shift at all going on. Okay, so number 2 that we had to look out for was a vertical stretch. Are there any vertical stretches going on here? Yeah, right, there is a vertical stretch of 2, right? So it looks like we're doing a vertical stretch by 2. Okay. Once we're done doing that, we have to do the reflections across the x-axis or y-axis. Is there a reflection here? Yes. Is it across the x-axis or the y-axis? The y-axis, right? Because the negative is attached to the x and it's not on the outside of the function. So this is actually a reflection about the y-axis. Okay. Finally, it says we have to look out for vertical shifts. How am I vertically shifting? Down 1 or up 1? Down 1, good. So vertical shift down 1. Okay, so first let's do the vertical stretch. That seems like a good place to start. So vertical stretch by 2. Okay. Remember, we do vertical stretches by making our table and multiplying by the number with the y values. Okay. So I'm going to have my x and y values. The points I'm putting on my table are the points on the last graph that I drew. Okay. So I got 0, 0, 1, 1. And just because I feel like it, let's do the 4, 2. Okay. Then I multiply everything by what I'm vertically stretching by, which is 2. So 0 times 2 is 2. 1 times 2 is 2. 2 times 2 is 4. Okay. So I can go in and draw my new points. 0. Oh, sorry. 0 times 2 is not 2. It's 0, right? Okay. My one mistake every class, right? Or multiple. Okay. So I got 0, 0. I have 1, 2, and 4, 4. So this is what my graph looks like now. Okay. Next, it says I need to reflect about the y-axis. So I'm going to pretend my y-axis is a mirror. Every point is going to be flipped over the mirror. Okay. So over here, I'm going to reflect across y-axis. Okay. Which function am I flipping over the y-axis? Am I flipping over the graph on the left or on the right? Oh, that's pretty good. All right, am I flipping the graph on the left or on the right? The right, right? Because the graph on the right is what I just drew. I'm transforming each function step by step. So I'm gonna take my blue graph on the right and reflect it over the y-axis. I'm gonna take my 0 point. Well, that's already on the y-axis, so I don't have to do anything there. My point 1, 2 is 1 block away from the y-axis on the right. So I'm gonna put it 1 block away from the y-axis on the left. So that goes here. And then 4, 4 is 4 blocks away from the y-axis on the right. So in order to bring it to the left, I would need to bring it 4 blocks away on the left. So that point would go here. Okay. Once I'm done doing that, I know what my shape looks like, so I can draw my shape. Oh, wow, that's really bad. There we go. So now it looks like this. Okay. Finally, it says I need to vertically shift down 1. So I'm going to take all my points and shift it down 1. Okay. So let me do it in green here. Okay, so I'm doing a vertical shift down 1. I'm going to take my, oh gosh, did not mean to do that. My 0, 0 point, shift it down 1 to 0, negative 1. I'm going to take my negative 1, 2 point, shift it down 1 to negative 1, 1. And I'm going to take my negative 4, 4 point and shift it down 1 to negative 4, 3. Once I'm done doing that, I can finish up my shape. Looking at my list of transformations, I don't have anything else to do. So it looks like this is my final function.